Okay, now what we're going to do is complete the square. And I'll go back to the blanks at the top, but what I want to do is I'm going to take out these equal zeros. I'm only going to do 2 of these because this middle one you can actually factor. But when you're completing the square, you are looking for basically vertex form of the parabola. Do you remember that, where you would say, oh, the vertex is to the right 2 and down 3 or whatever? Okay, so when we complete the square, what we're looking for is something that is factored as a quantity squared, like x plus 2 squared, and then you're going to have like minus 7. Now remember, when you have an expression or an equation, you always have to keep it balanced. So if you add something, you also have to subtract that same thing so that your function still is the same. Does everyone understand what I mean? Meaning if I add 9, I have to subtract 9. So really I'm just adding 0. Okay, you can change what it looks like, you just can't change the value. So we're going to practice here first. I do not have 2 factors of 3 that add up to 8. So what I'm going to do with this expression is actually create a perfect square trinomial that I can factor. Meaning I'm keeping my x terms grouped, and then I'm going to push that 3 down. So I'm just going to put it in parentheses so you can see. This is x squared plus 8x, and then I'm going to have plus something here, and I'm going to close off this parentheses. All I did was move this down. But whatever I add here, I'm going to have to subtract that same thing because I need to add 0 basically to this expression. What goes in the blank? It is 16. Okay, for those of us that have forgotten, you take your b value, which in this case is 8, you divide it by 2, and you square it. Now essentially, this is really 4 squared, true? Okay, this number right here is actually your factor. Meaning, what 2 numbers multiply to 16 but add up to 8? 4. It's right there. It's your factor. And that's actually going to come into play when we do C. So here, when I write this as x plus 4 squared, this becomes what? Minus 13. Okay, that's vertex form. Okay, it's not pretty, and the next one is going to get even worse because there's a fraction, but it's completing the square. So let's go down here. When you complete the square, your leading coefficient has to be 1. So that means I need to divide everything here by 2. So when I do that, that leaves me with x squared minus 3x, and I'm going to group these. Okay, this becomes minus 5 over 2 because I divided everything by 2. And remember, whatever you add, you have to subtract. Okay. The bad news here is that my b value is not an even number. That means it's not evenly divisible by 2. So I'm going to write it as the quantity squared, just like I did before for the 16. I wrote it as 4 squared. What's the number that's going to go in here? 9/4. It's going to be 3 halves squared. So I'm going to write it as 3 over 2 squared, and this is 3 over 2 squared. Okay, I'm writing it like this because remember what I said in A? This is my factor. So when you write this as the quantity that is your factor, this becomes x, and remember you bring down this sign, it's minus 3 over 2 squared. This right here is minus 5 halves and minus 9/4. So this becomes minus 19 over 4 when I combine the fractions. Okay, so this is what I wanted to show you. Here, completing the square. This is your factor. You always take the first sign when you're completing the square. This is your factor. You always take the first sign when you're completing the square. Okay, because it's actually going to come into play. So when we're integrating by completing the square, what you're looking for is either a 1 or a dx in the numerator. You're looking for a 1 or a dx in the numerator. So the other thing that I want to tell you is that your answers are either going to be an inverse sine or an inverse tangent. So remember, long division is either inverse tangent or natural log. How do you know you're going to have an inverse sine? What's a dead giveaway? Yeah, you're going to have a radical in the denominator. So that's how you know what you're looking for. Okay? So when I look at all 3 problems on page 4, do I have an inverse sine here at all? No, I don't. We're going to be dealing with inverse tangent. So now you know what you're looking for. So that means I need to manipulate this problem so that I get 1 over 1 plus x squared or u squared or whatever. Okay, so I'm going to have to do a u sub. I'm probably going to have to factor some things out. Okay, so you just have to be careful. All right, so we're going to start with number 1. We're going to rewrite this problem. We've got the integral 1 over. Now, we need to push this down, okay, and leave space so that we can complete the square. So I've got x squared plus 2x plus something, and then I've got plus 2, so whatever I add here, remember you have to subtract the same thing. And I'll throw my dx on the end, just like this. Okay, what goes in that spot? Yeah, I've got a 1 squared, which is 1, and then a 1 squared, which is 1. Everybody okay? All right, this right here, you're going to factor. All right, so I've got the integral of 1 over, what's my factor? X plus 1, the quantity squared. Okay, and then this becomes what? This is nice. Yeah, it's plus 1, and then I've got dx. Okay, this is almost exactly what I want. I need this to be just one term, so this would be my u sub. Does everyone see what I'm looking at? Okay, so if I said that u is equal to x plus 1, that means I need to get rid of this dx, so du is equal to dx. So this is what I have, and I'm actually going to rewrite this so that it looks like the inverse tangent, meaning I'm going to put my number first. Integral 1 over 1 plus, what is it, u squared du. Nice and quick, right? A lot quicker than a long division. So this is now inverse tangent. Okay, more specifically, inverse tangent of what? Yeah, x plus 1, and don't forget, plus c. Okay, questions? Okay, that went a lot quicker than the long division. Okay, I am highly recommending that you watch the video for number 2 because I'm going to move on to number 3. This is it's got a bound. Okay, and we're actually going to leave it in terms of u. So we're going to use that table that we did when we did the last section in the first part of the unit. Okay, so we're still going to do everything as we did in the previous problem. Okay, you've got the integral from 3 to 4. Okay, I'm going to make this numerator a 1 now. I've got the x squared minus 6x plus, and you got plus 10, and this will be minus, and then the dx is here. So can someone tell me what goes in this blank? Yeah, a 9. Okay, is there anyone that doesn't see where that 9 comes from? Okay. So now I'm going to factor this. Okay? So you've got the integral from 3 to 4 of 1 over x minus 3, the quantity squared. And luckily for us, this becomes plus 1 dx. Okay, we're going to make our u sub. So what's my u? It is x minus 3. So I'm actually making my table over here because I'm going to change the bounds. X and then u. So I'm going to copy this directly over. This is a 4. This is a 3. So what's u here? 1 and 0. All right, so now we have the integral from 0 to 1 of 1 over 1 plus u squared du. Here's my question. Are my bounds proper? Meaning, are they in the right order? Smallest to biggest. Yep. Okay. What is this? It is inverse tangent. Inverse tangent. Do I have to put the x minus 3 back in here? I reset the bounds. So do I have to put it back in?
No.
No. So I'm just going to leave it as u. And I want to evaluate from 0 to 1. So what I'm saying is the inverse tangent of 1 minus the inverse tangent of 0. Okay. This means what angle do I take the tangent of to get 1? Unit circle. Pi over 4 is correct. What angle do I take the tangent of to get 0? It's asymptote. 0. Remember, okay, guys, you got to remember your domain restriction for inverse tangent. So it goes from negative pi over 2 to pi over 2, but at negative pi over 2 and pi over 2, what do we have? Yeah, undefined, so those are asymptotes, so those don't count, right? You have 2 less values. So that means this is just 0. So this answers pi over 4. Yes.
Why is it not 2 pi?
Why is it not 2 pi?
We give it a restriction though.
Yeah, you have your restriction. The restriction